kids, today I'm gonna explain the practice problems. I have selected a few questions from the chapter 4, 4.1, 4.2 and 4.3, which deals with Newton's first law, second law and third law. First question. A rope lifting a bucket at a constant speed. If you draw a rope and a bucket, so this is our system. And here I use the particle model and I identify all the forces. So bucket has some mass, so it has some weight. That is the mass on the bucket, that is the downward force, which also can be written as Fg equal to mg. It is a downward, so later on if I want to take this force, I have to consider the negative sign. Upward force, the rope on bucket. So you are lifting or hanging the bucket to the rope, so the force of the rope on the bucket upward direction. In later on we will call this one as a tension. So for now just a rope on bucket. So if you just drawing this one, not tell us whether the system is moving or not. So we have to tell what happened to the speed, the constant speed and the upward direction. So we know the direction and the magnitude, so that's the velocity. It's the constant velocity. That's it. This representation tells you the object is with the constant speed moving upward direction. Therefore, what happened to the acceleration? A equal to 0, because here change in velocity is 0. If A equal to 0, the net force, mass times acceleration, is equal to 0. Next, question number 2. So we have 3 dogs pulling the sleigh. One dog pulling with the 35 Newton, another with the 42 Newtons. A confused dog, so pulling opposite direction to the other 2 dogs with the 53 Newtons. So I represent them with a vector notation. 2 dogs east and another dog west direction. So the net force on this sleigh is equal to sum of all forces. I have to add all forces, and you have to carefully substitute the values because one of these 3 dogs is in opposite direction or west. Therefore the net force here 24 newtons. This is the question, and from this we got net force 24 newtons. Because the positive sign we got net force, that means the one dog is with the 53 Newton is pulling backward, but still the sleigh is moving forward. Next, question number 3. We have a watermelon on a scale. Scale pushes the watermelon upward direction, and watermelon has some mass, so it has some weight, it's a downward direction. The scale supposed to show weight of the object. We know that weight equal to mass times the gravitational field. 4 times 9.8, you will get 39.2 newtons. That is newtons. So we don't need to put the negative sign, so we'll take just we know that weight is a downward direction. Whenever we deal with the weight, we just take the magnitude, we consider the magnitude. Always the gravitational force is always downward, so we don't mention that. So what is the force mother need to apply on her? The force by mother on the child is equal to the acceleration and the mass of the child. Question number 5. Tharu and Rekho, 2 people are pulling a rope of 0.75 kilogram. Tharu pulls with the 16 newtons And Reiko, we do not know what is the force applied by Reiko, but one thing we know that even though Taro is applying 60 Newton, the rope is moving away from the Taro. That means Reiko is applying more force than Taro. Here our goal is finding the force of the Reiko. Here if you take Taro is pulling west, the acceleration of the rope is towards the east, the positive direction. Therefore F net equal to sum of all forces. Reiko, I took Reiko direction towards the east, therefore the Taro force opposite to the Reiko, so I have taken the negative sign here. If I substitute all the values, you will get force of the Reiko 16.9. So Taro force is 16, Reiko force is 16.9. So that is why the rope is accelerating towards the Reiko or away from the Taro. Question number 6. So here they gave us weight on Earth. We have to find the mass. We know the weight equal to mass times the gravity. M times 9.8, you can find the M from there. But with the same mass, if it is on the moon, what will be its weight? So we have to use the moon's gravitational field value 1.6. Moon equal to mass times the gravity on the moon. 59.69 times 1.6, you will get 95.5. So you can see the weight on the Earth, weight on the moon are different. Though object mass is same, it has a different weight on Earth and moon. Moon is smaller than the Earth, so the G value is less, 6 times less than Earth G value. Question number 7. Elevator and the scale case. So remember the formula. The scale reading or force of the scale on the object. Force of the scale on the object is equal to mass times G plus A. A value depends on the direction. You have to substitute the positive or negative. You need to see the situation accordingly. You have to substitute the A value. Question number A. The elevator moves at constant speed. Elevator moves with a constant speed. That means A equal to 0. No acceleration. Therefore, the scale reading is equal to mass times the G. It is the weight of the object. So here the operant weight equal to the actual weight. Question number B. While moving upward with a 2 meters per second square acceleration, that means we have acceleration, substitute the acceleration in the formula. Do not put G value is negative here. Here we have taken in the beginning the net force. Here we have two forces. One is the person weight on the scale downward direction, or we can say it at mass on the person, which is weight of the person downward direction, and scale is pushing the person upward direction, which is always positive. The F scale on the person upward direction. The net force is equal to sum of these two forces. One force is upward, another force is downward. So I have taken the downward force as a negative already. So do not take G value again negative here. We have taken it already. So therefore we know the formula F scale equal to M times G plus A. Here A equal to positive 2. So plug in. Therefore F scale equal to 885 newtons. Case C. Case C also the lift is moving upward with a 2 meters per second square acceleration, but it slows down. If it slows down, what happened to the A value? Is it positive or negative? So if you can remember, A should be negative. If it's going up, slowing down, A should be negative. But if you do not know, or if you're confused whether it's a positive or negative, so you can find yourself. For example, take Vi equal to plus 2 meters per second square, Vf final velocity 1 meters per second square. That means it tells you the object is moving upward direction and is slowing down, so it satisfies the condition. Therefore, change in velocity is equal to Vf minus Vi. So change in velocity we got negative. Therefore, acceleration is equal to rate of change of velocity will also be negative. So this way you can check whether you are writing the correct sign for the A or not. So we know now A equal to negative 2. Plug in the value here. So you will get F scale equal to 585 newtons. Now object is speeding up but downward direction. So here also we will get A value negative. But still, if you cannot remember this, so take some random numbers and check yourself. Here I took Vi negative 5 meters per second square and Vf 10 meters per second square. It tells us the object is moving downward direction and is speeding up. So change in velocity, I got negative. So therefore acceleration should be negative 2. So plug in the A value negative 2 in the formula, you will get F scale reading 585 newtons. Moves downward at a constant speed. It doesn't matter it's moving up or down. If it is a constant speed, that means A equal to 0. So plug in the A equal to 0 in the formula, you will get the F scale reading, means the force of the scale on the person, which is upward direction, which is always upward direction, 735 newtons. If you get F scale reading in negative, means you have done mistake somewhere. You can double check with that. So F scale should be a positive reading, a positive value, because the scale is pushing the person upward direction. So here we have taken a rope and a bucket hanging to it. So let us see what are the forces acting here. The downward force, mass times the gravity, the upward force. So here, because of the hanging mass, the rope will experience the tension. So the force applied by the rope on the bucket here we can call tension. Tension here, upward direction. So net force equal to tension minus mg. I have taken the here negative sign already because here the force is downward direction. Therefore, from this equation we can focus on acceleration. That's what they ask us. But let us take Ft value as a maximum. 450 newtons means the rope can handle only the tension up to 450 newton only. So if you take the maximum tension value, so you're gonna see maximum acceleration you can apply. So from this calculation I got acceleration is 0.9 meters per second square. What does it mean? If you apply the acceleration to the system more than this 0.9, more than 0.9, that means let us say 1 meters per second square, the rope gonna break, because if A value exceeds 0.9, so the total tension in the rope will exceeds 450 newtons. So then rope will get broken. Question number 9. Here I have taken the bottom rope tension as a Ft1 and Ft2, which in red color, is a top rope tension. So therefore tension in the bottom rope. So consider the mass 1, mass 2, both of them as a single mass system. So on the top rope we will get a more tension because two masses are hanging there. So add the two masses together, m1 plus m2 times the gravity. So we will get total tension here. So the tension here in the top rope is equal to double than the tension 1 in the bottom rope. In this case, what will be the tension in the bottom rope and what will be the mass of the top block? Ft1, tension in the first rope, is equal to the mass hanging on the rope times the G value. So that is the new mass here, 3 kg times 9.8, you will get 29.4 newtons. Two masses are hanging on the top rope, so we know only one of them, those two masses, and also we know the tension in the rope, the top rope. Therefore the unknown value m2 equal to 3.4 kg. Baseball is being caught. Its speed goes from 30 meters per second to 0 meters per second. The short time. The mass of the baseball is 0.145 kg. So baseball is traveling, so you hit the baseball with the baseball bat. It travels with the 30 meters per second, then it slows down up to 0. So the acceleration will be negative 6000 meters per second square. What will be the force acting on it? We know the mass of the object, a baseball, and its acceleration. So the force acting on this baseball is 870 newtons. The Newton's third law, we can say that force of the ball on the hand equal to the hand force on the ball should be equal but opposite in direction. That's why F1 is a negative, so therefore F2 will be positive.